this lecture. Now, I wanted to come back to a point about how hurricanes are mainly occurring over the ocean, and how when they move over land they very quickly dissipate. This is, of course, again related to this basic problem that hurricanes have. Once they move over land, they're going to begin to weaken and die. Their pressure is going to start going back towards normal, their winds are going to get weaker and weaker, and so on, simply because they're running out of energy. They are running out of water vapor to condense and get that latent heat release and so on. As they have heavy rains, as the storm continues to make its way on land, there's just not enough evaporation over the surface. Part of the story, too, is the winds are just weaker. As the winds are blowing over the surface, there really isn't that much water over the surface compared to of land versus over the ocean. And there's too much friction. The winds are going to be slower over land than they were over the ocean. So for both reasons, honestly, hurricanes weaken dramatically, even passing over a very small obstacle, like a small tropical atoll or something like that. If they move onto the mainland, their winds are going to be dramatically weaker within the first 15-20 miles. That doesn't mean that they're not going to continue to have a lot of rainfall as they move ashore, and it doesn't mean that they aren't going to continue to cause death and destruction as they move ashore, but they're going to be weakening dramatically as they move ashore. And let's use that as a way to kind of launch ourselves into a discussion about how hurricanes cause death and destruction. I mean, when hurricanes are out over ocean, they are made up of hundreds of thunderstorms, maybe thousands of thunderstorms, all working in concert to create this circulation and so on, and realistically they're not really hurting much of anything unless there's like an oil drilling platform in their way. But once they make landfall, all kinds of things can go horribly wrong. The first way in which we can have a lot of destruction associated with hurricanes has to do with the heavy rains. Now that is not necessarily right at the shore, because as the hurricane moves inland, all that water vapor that's in the volume of air that is the hurricane is going to eventually fall out as rain, and so depending on how fast it's moving and so on, that can mean a lot of rain. For example, here I have a map of the track of Hurricane Katrina in 2005, and of course it dumps enormous amounts of rain that kind of goes off the scale down there in like New Orleans and so on. But look at like southern Indiana and Ohio and so on. These places got like 7 inches of rain out of Hurricane Katrina. Obviously, it was no longer a hurricane. It had long since lost tropical storm strength winds and so on when it moved far inland. But the rain was still very heavy. In fact, in the United States, this tends to be the single largest source of fatalities associated with hurricanes because, well, frankly, we're pretty good at evacuating the counties right along the coastline. You know where we don't evacuate when a hurricane is coming? Indiana or Tennessee or something like that. So those people are right there where the damage is happening associated with all this inland flooding and so on. So this tends to be the most deadly part of modern hurricanes in the United States. Obviously, a lot of death and destruction from hurricanes comes from the strong winds that they bring ashore. Now, while the hurricane is far out to sea, a Category 1 hurricane has 74 miles per hour wind, which is an astonishing wind, and it might be Category 2, 3, 4, 5, all the way up to like 150 miles an hour or more. But once that storm comes inland, we've just talked about the fact that a lot of things go wrong for the hurricane. And so, like, here's a map that just shows some of the counties right there in North Carolina, rather, when a particular hurricane, this happens to be Hurricane Sandy, came ashore in 2012. And you can see that there were very strong reported winds. I can't read the scale on my little tablet here, but, very strong winds like on the Barrier Islands and in the first maybe 5 miles of the coast. But even like one county inland, the winds are, what is that down there, less than 36 miles per hour. That's still a gusty day, but there's not going to be damage and so on from winds like that. The truth of the matter is, this is going to be primarily a phenomenon right near the coast. Which means that, well, because we're pretty good at evacuating the coastline, honestly, we don't get a lot of deaths associated with the strong winds from hurricanes, especially in the United States. Now, damage is another story. Destruction can be kind of spotty when you have strong winds. Here's this thing. The winds in a hurricane, frankly, aren't that strong. Okay, 74 mile an hour winds, let's just say. Let's say that's a Category 1 hurricane, just round numbers, let's say 80 mile an hour. The truth of the matter is, almost any house, frankly, even relatively poor construction like mobile homes, can survive an 80 mile an hour wind. That is just part of the building code. I mean, anytime the gust front of a thunderstorm comes through, you might have a gust of like 80 miles an hour. We can't have the roofs coming off a house every time a thunderstorm comes through. Building codes are built stronger than that. And so the truth of the matter is, even 120 miles an hour, even 130 miles an hour, any reasonably well-built structure can survive that. The problem happens when there's a debris cascade. A debris cascade is when one structure fails, like maybe a tree falls onto that building, and then the wind can get into, the structure has been compromised. The winds can get into the building, can get up under the roof and lift the roof off the building. Your house has probably been built to withstand a wind of 120 miles an hour or 150 miles an hour. What it hasn't been built to withstand is having your neighbor's roof crash through it at 120 miles an hour. Okay? So you get these so-called debris cascades where one structure fails for whatever reason, and then it makes the buildings next to it fail, and that makes the buildings next to that fail, and so on. Well, that's extremely hard to predict and extremely spotty. So wind damage tends to be very spotty. That's in contrast to the third and most destructive part of a hurricane, which is the so-called storm surge. Storm surge is an increase in sea level that happens during a landfalling hurricane. So the sea level is actually higher during a hurricane than it is under normal conditions at that same phase of the tides and so on. What are we talking about? In the range of like 4 to 8 feet is average. It can be more like 12. It can be more like 1 foot. It's actually extremely complicated to forecast storm surges we're going to see. But this does typically tend to be the most destructive part of a storm. When you look at a picture like the one in the background there during the landfall of a hurricane, and you can see this water, around structures and so on, that's salt water. That's not like flooding from the rain. That is salt water. That is the ocean coming up into these structures near the shore. Now, when I say that it's talking like 4 to 8 feet higher than normal, I don't mean 4 to 8 feet farther up the beach. I mean 4 to 8 vertical feet. Depending on the slope of the shoreline and so on, that might be a mile inland that the water is penetrating. Well, this becomes the most destructive part of most hurricanes. In part because we can't build structures in any cost-effective way that can survive being underwater, much less moving water. You can make your house survive 120 mile an hour winds, but there's just no cost-effective way to build a house so that its foundation isn't undermined by being under moving water, or that it doesn't separate from its foundation when it's under those moving water. There's just no cost-effective way to do this. If there's storm surge at your house is a loss. Wind damage tends to be spotty, where a storm surge is widespread. It isn't like my house had storm surge damage, but the house next door didn't. If my house is underwater due to the storm surge, or the house next door is going to be too. So you lose entire areas. Whereas, if you're just talking about wind damage in a neighborhood, some number of the homes, some fraction of the homes will have been damaged or destroyed, but other ones will be fine. If that neighborhood is affected by storm surge, the whole neighborhood's underwater. They're all a loss. There's more reasons why a storm surge is so expensive. Part of the story is it takes out things that aren't normally affected by, like, the winds of a hurricane. Like expensive civil construction projects like roads and bridges and canals and sewer systems and so on. No matter how windy it isn't going to be taking out a length of the interstate highway. Whereas put that interstate highway under moving water, and the waterways will erode the roadbed, and the roadbed will be collapsing and so on. You've got to rebuild that whole thing. Or that bridge is no longer safe for travel because we have eroded the pilings of the bridge or something like that. Or the back pressure of having all that deep water right there put too much back pressure on the sewer system, and it burst the pipes in almost unlimited number of places in this neighborhood. You have to replace the whole thing. These are enormous uninsured costs that have to be replaced after a hurricane has passed. Also keep in mind that we just tend to put the most expensive stuff right by the coast. Now, your picture in your mind might be, yeah, that's right, we put, high-rise apartments and condos and hotels and casinos and so on right by the coast. You hardly ever see any oceanfront view mobile home parks. That's true, but keep in mind, there's also like the whole story of infrastructure that we put right there along a coastline. Like harbors and docks and for loading and unloading oil oil tankers and so on. All that infrastructure that we use for those kinds of things. Just the dredging of the channels that the ships use and so on. That's all enormously expensive, and it's all right there on the coast where the damage is going to be the greatest. Now, historically, this was also the most deadly part of hurricanes, but that isn't the case in the United States anymore. But it still can be terrible around the world. You may have heard of the so-called Bola cyclone. The Bola cyclone was a hurricane in the Bay of Bengal off the east coast of India in 1970. Officially, 250,000 people died, but actually I have 300. I'm sorry, there's a misprint on the slide. It's 300,000, not 30,000. But unofficially, more than 1 million people are thought to have died in that storm. Mostly it affected Bangladesh, which is a very low-lying country, and there was just no place to go during the storm surge, and enormous numbers of people died. Actually, I could tell you all kinds of stories about how they've adapted to that problem, but you need to take my tropical meteorology course if you want to see that. In the United States, actually, our most deadly natural disaster was the so-called Isaac's storm back in 1990. This was long before we named storms. Isaac's storm is actually the name of the book that was written about this storm. It's named after Isaac Klein, who was the meteorologist in charge for Galveston when the storm was coming. And it's a long and interesting story about why this particular storm was so dangerous and so on. But Galveston was a great city in coastal Texas at that time, and somewhere in the range of 7,000 to 8,000 people died in the storm surge as the storm came ashore. There's a great, well, horrible story in the Isaac's storm book that talks about how, like, when people realized that it was time to evacuate, all the horrible fatalities that happened. I'll tell you one story that I seem to recall from the book. If I remember right, there was an orphanage that was trying to evacuate once the water had gotten too high. And the people who ran the orphanage had this idea that they were going to keep the kids from being separated from each other in the storm as they made their way to the bridge by having a long length of rope, and they tied each child's hand to the rope as they went out, so that they would all be together. And when the waves started pulling the kids at the back end of the line out to sea, they dragged all the other orphans out to sea too. Horrible stories. The Isaac storm is a good example, though, of the kinds of damage, that death and destruction you can see associated with storm surge. And have you ever been to Galveston? I mean, it's nice, but it's, I don't know, 30,000, 40,000 people or something. It's not a great city anymore. Galveston never really recovered. All the industry and things like that moved to nearby Houston, which was not really a thing in 1900. And now Houston is, what, the 6th largest city in America. I mean, Galveston just never really came back. It's kind of just a tourist city now. If storm surge is really the part of the storm that you're least familiar with, you can be forgiven. I mean, most of us don't live in parts of the world where storm surge happens associated with this. Let's talk about why storm surge happens. Well, part of the story of why storm surge happens to be about the low pressure at the center of a hurricane. Now, I drew and scanned kind of a very cheap little diagram right there to illustrate why the water is higher in the center of the hurricane than it is around it. For all intents and purposes, the surface of the ocean becomes like a barometer. Remember how barometers work, where the pressure of the air around the barometer pushed the mercury up that column where there was lower pressure? It was actually a vacuum at the top of the column. In exactly the same way, the heavier pressure, the greater pressure around the hurricane pushes down on the surface of the ocean more than the lower pressure at the center of the hurricane does. And so the surface of the ocean literally bulges upward like the mercury in a mercury barometer in the center of the hurricane. Now, this only tends out to be responsible for somewhere around 75 centimeters, maybe 100 centimeters or 1 meter of this total storm surge, but that can be a lot. Okay, that's certainly a big part of the story of the storm surge. Remember, we gave you the number of like 4 to 8 feet. That'd be about 1.5 to 3 meters roughly. So a sizable chunk of the story is about the low pressure of the hurricane itself. Another part of the reason why we get such high storm surges during a hurricane is literally just the heavy rain itself. Remember, hurricanes produce enormous amounts of rain. I mean, at a given location, it would be nothing to see 12 inches of rain. Well, but when that water falls on the ocean, it isn't like it can run away. Water falls on the land, it runs downhill. On the surface of the ocean, it just makes a pile of water. Okay, so if it rains a foot of rain on top of the ocean is a foot higher for a while. Eventually, ocean circulation spread that out, but originally, anyway, on the order of the hours of the storm making landfall and so on, the ocean is literally a foot higher. And again, we're talking a foot higher, not a foot farther up the beach. a foot higher might be a quarter mile farther inland on the beach. Okay, well, maybe not a quarter mile, but certainly a long ways inland. That is an additional factor that is contributing to the storm surge. Although, in fairness, there is the biggest single factor, but unfortunately the hardest one to predict, has to do with the strong winds. The strong winds around a hurricane create circulations in the ocean, and as that hurricane is moving inland, on the right side of the storm, if you're facing the way the hurricane is moving, on its right side, that means it is pushing water towards the land. There's no place for the water to go but up the beach. Again, this might only be responsible for a meter or so, or like 3 to 4 feet of the storm surge, but again, that is on top of those other factors. Now we're adding up to a storm surge that might be 8-9 feet vertically, which might be a mile inland that it can push the water. Hey, if that means that as the storm is coming ashore, on the right side of the hurricane where we're pushing water towards the shore, does that mean on the left side of the hurricane where we're pulling water away from the shore, the water levels are actually lower than usual? Yeah, absolutely, it does mean that. How come I've never heard about that, Dr. Shraggy? You've never heard about it because it doesn't cause any damage, right? Pulling the water away from the shore might mean that if there's any boats along the shoreline, like they'll be laying there in the mud for a few hours as the hurricane makes landfall, and then the water will come back and they'll float again. It doesn't result in really any damage to speak of or anything. Sometimes when a hurricane makes landfall, you see pictures like that on the news, but they don't hurt anything. It's on the right side of the storm where the winds are pushing the water towards the shore that you get this incredibly strong storm surge. Now, the problem with storm surge is that it's just about impossible to make decent forecasts of it. This is part of the reason, by the way, why people who live near the coast take hurricane warnings pretty seriously. Part of the story is we just are so bad at predicting how good the forecast will be. I want to show you an example of how bad these forecasts can be. This happens to be Hurricane Ike in 2008. It's notorious for having how bad the forecasts were. If you look at this is supposed to be a forecast of how high the storm surge will be along southeast Texas and Louisiana and so on. And it looks like right there around Houston, let's see, we're in that dark red, it's saying 25 feet of storm surge. So the water in Galveston Bay and Houston and so on is going to be 25 feet vertically higher than usual. Well, 25 feet of vertical elevation, that whole county is going to be underwater. No, we'd never see storm surge anywhere like that. I'm putting this here not because there was 25 feet of storm surge during Hurricane Ike, but to show you how bad the forecast can go. The actual forecast made by the models and so on for Hurricane Ike was predicting a basically impossible, apocalyptic amount of storm surge. You know, whereas the real number was probably more like 4 feet of storm surge, which in and of itself caused lots of damage. Ike actually made landfall a little bit farther off to the east than this anyway. But it's just too hard to make these forecasts because what actually determines how much storm surge there is going to be is dependent on a lot of things that we don't really understand very well. Part of it is the shape of the coastline, which is a more complicated issue than you might think, but even more fundamental is the shape of the bottom topography of the ocean at these locations, where how steep is the slope below the waterline, and how are there little valleys under the waterline, and moving sandbars and so on. Sandbars below the surface of the ocean, by the way, that might even be moving during the storm. So we don't even necessarily know what the bottom topography of the ocean is right at this moment because it's changing because of the approaching hurricane. For that matter, the lunar tides, the actual daily cycle of the tides, is part of the factor. I mean, obviously, if the storm surge happens at high tide, you have to add the lunar effect to the tide to the storm surge. Well, we aren't even all that great at predicting lunar tides. Turns out lunar tides are actually surprisingly complex to predict too. Alright, so just to wrap up what we saw in this lecture here, remember we learned all about like the size and strength and terminology that we use when we're talking about hurricanes. We learned about how we name them and where they occur and where they don't. We learned about the tracks that they typically take. We learned about the structure of the storms, like eyes and eye walls, rain bands, and the circulation at the surface and the circulation near the tropopause. We learned about the Hurricane Cookbook, which told us lots about where hurricanes could and couldn't happen, and for that matter, when they could and couldn't happen. We learned about how hurricanes cause damage by their strong winds, their heavy rains, and their storm surge. And we learned about what causes storm surge and why it's so destructive. Alright, now that we have all that information, let's answer 3 more questions. Question 7. In the United States, the deadliest part of a hurricane tends to be A. Flooding inland due to heavy rains as the storm dies. B. Strong winds right along the shore. C. Strong winds far inland as the storm dies. Or D. The storm surge far inland as the storm dies. Which of these causes the most fatalities in the United States? Make a choice from those 4 options and get a little feedback before we move on to question 8.